Here's an expensive question. Did you leave gas in your mower over the winter? If the answer is yes, there's a decent chance your carburetor spent the last few months marinating in something that resembles sticky varnish more than gasoline. And unfortunately, your mower is about to let you know exactly how much it hated that idea. The problem is that modern gasoline has a dirty little secret. Unlike the fuel your grandfather probably poured into his mower 30 years ago, today's pump gasoline usually contains up to 10% ethanol, commonly labeled E10. Ethanol helps reduce emissions, but it also has one unfortunate personality trait. It's hygroscopic. That's a fancy way of saying it behaves like a sponge. Ethanol naturally attracts and absorbs moisture from the air. Every time the temperature changes inside your garage, the air in the fuel tank expands and contracts, pulling tiny amounts of humid air in and out. Over the next few weeks, that ethanol absorbs more and more water until something called phase separation occurs. Imagine pouring oil and water into the same bottle. Shake it hard enough and they'll appear to mix, but leave the bottle sitting on the counter for a while, and they'll naturally separate into different layers again. Fuel behaves in much the same way. The heavier mixture of water and ethanol sinks to the bottom of the fuel tank, the exact place where your mower draws fuel first, while the gasoline floating above it loses much of what made it combustible in the first place. By the time spring arrives, your mower is taking a gulp of watery ethanol, followed by stale gasoline, that's been quietly deteriorating all winter. And that is only half the problem. As gasoline ages, its lighter, more volatile compounds begin to evaporate. At the same time, oxygen reacts with the remaining fuel in a process known as oxidation, producing sticky gum deposits that eventually harden into varnish. That's essentially what old gasoline does inside your carburetor, and that is where things get expensive. A lawnmower carburetor isn't just a metal container holding fuel. It's a precision fuel metering device, containing incredibly small passages, some only fractions of a millimeter wide. Fuel collects inside the float bowl, where a float and float needle work together much like the float inside a toilet cistern, constantly maintaining the correct fuel level. From there, gasoline passes through the main jet, pilot jet, and emulsion tube, where it's mixed with air before entering the combustion chamber. Sometimes the problem goes beyond smoke. If enough oil finds its way into the cylinder while the piston is traveling upward on the compression stroke, the piston suddenly tries to compress something that simply won't compress: liquid oil. Mechanics call this hydrolock. Suddenly, the mower becomes difficult to start, loses power under load, backfires unexpectedly, or simply refuses to run properly. At that point, many homeowners spend hours cleaning the carburetor or replacing spark plugs, when the real culprit is a damaged flywheel key caused by one unfortunate encounter with a buried rock. Thankfully, preventing all of this is surprisingly simple. Whenever you sharpen your blade, don't just check whether it's sharp, check whether it's balanced as well. A simple cone blade balancer costs only a few dollars and immediately tells you if one side of the blade is heavier than the other. If one end consistently drops, remove a small amount of metal from the heavier side until the blade sits perfectly level. Unlike air, liquids are virtually incompressible, so when the piston reaches top dead center, something has to give. In mild cases, the engine refuses to turn over and the starter rope feels like it's been welded solid. In more severe cases, the connecting rod can actually bend because it was never designed to compress a liquid in the first place. All of that can happen simply because you wanted to scrape a handful of grass clippings off the deck. Fortunately, this mistake is usually much easier to fix than stale fuel. The golden rule is simple. Whenever you need to clean underneath the mower, tilt it with the spark plug and air filter pointing upward. It's still worth checking your owner's manual though, because some manufacturers specified the exact direction their engines should be tilted. If you've already flipped the mower the wrong way, resist the temptation to keep yanking on the starter rope and hoping the problem sorts itself out. Remove the spark plug first, then slowly pull the starter cord several times to push any trapped oil out of the cylinder. After that, inspect the air filter. If it's soaked with oil, replace it. Or if it's a reusable foam filter, wash it thoroughly, let it dry, and re-oil it before reinstalling it. Once everything is back together, there's a good chance the mower will return to normal after producing one dramatic, but completely harmless, cloud of smoke. Unlike stale fuel, which quietly destroys a carburetor over the course of several months, this mistake usually makes its presence known immediately. That's actually the good news, because most people stop using the mower before permanent damage occurs. The next mistake is far less obvious. Your mower will often keep running as if nothing is wrong, all while slowly vibrating itself to pieces from the inside. A lawn mower blade isn't just a sharp piece of steel. It's a carefully balanced rotating mass. Manufacturers spend a surprising amount of effort making sure both ends of the blade weigh almost exactly the same, because even the tiniest difference in weight becomes a massive problem once that blade starts spinning at roughly 3,000 revolutions per minute. Manufacturers don't balance mower blades for comfort. They balance them to protect the crankshaft. A smooth-running mower is really just a sign that all the rotating components are staying in perfect mechanical harmony. Mechanics call this dynamic imbalance. The moment one side of the blade becomes even slightly lighter or heavier than the other, centrifugal force begins pulling unevenly on the crankshaft during every single revolution. Those forces might seem tiny on their own, but at 3,000 revolutions per minute, they add up astonishingly fast. Instead of rotating smoothly around its center of mass, the blade develops a slight wobble. That wobble travels through the blade adapter, into the crankshaft, through the engine mounts, and eventually into the handlebars you're gripping. So if your hands start tingling after only a few minutes of mowing, your mower isn't just vibrating. It's trying to tell you something is wrong. Unfortunately, most people ignore the warning signs. They assume the engine is simply getting old, or they convince themselves that all lawn mowers vibrate. Neither is true. A healthy mower should feel surprisingly smooth, and excessive vibration is almost always a sign that something needs attention. The real danger is what those constant vibrations are doing inside the engine. Every shake places additional stress on the crankshaft bearings, engine mounting bolts, and even the aluminum crankcase itself. Aluminum is lightweight, which makes it ideal for small engines, but it also has its limits. Subject it to enough repeated vibration, and tiny fatigue cracks can begin forming around bolt holes and mounting points. You won't see them straight away, but with enough time they can grow into expensive structural damage. By now, you've avoided stale fuel, resisted the temptation to tip the mower the wrong way, and made sure your blade is properly balanced. At this point, you'd think your mower should be set for a long, trouble-free life. Not quite. There's one more mistake that quietly cooks perfectly healthy engines every single summer, and most homeowners don't even realize they're doing it. Here's a simple question. Where's the radiator on your lawn mower? Exactly. There isn't one. Unlike your car, most pushmowers use air-cooled four-stroke engines. Instead of circulating coolant through a radiator, water pump, and thermostat, they rely entirely on moving air to carry heat away from the engine. It's a brilliantly simple design, but it only works if that airflow isn't blocked. As the engine runs, The flywheel does much more than store rotational energy. Built into it are fan blades that spin thousands of times per minute, drawing cool air through the engine shroud and forcing it across the cooling fins cast into the cylinder and cylinder head. Those cooling fins dramatically increase the engine's surface area, allowing heat to escape into the moving air much more efficiently. If you've ever looked inside a desktop computer, they work much like the metal fins on a CPU heatsink. More surface area means more heat can be carried away. Unfortunately, homeowners accidentally sabotage this system all the time. Every time you mow dry grass, dusty lawns, or piles of autumn leaves, the flywheel fan doesn't just move air, it also pulls in fine debris. At first, it's only a few grass clippings, then a handful of leaves, a layer of dust, maybe even some fluffy seed pods. Season after season, that debris collects underneath the engine shroud until the cooling fins are wrapped in what is essentially a thick, insulating blanket. Mechanics refer to this as restricted cooling airflow. I prefer to think of it as making your mower run a marathon in the middle of summer while wearing a heavy winter coat. Once those cooling fins become clogged, the flywheel fan can no longer move enough air to remove heat effectively. Cylinder head temperature begins climbing. The engine oil gets progressively hotter, and its viscosity starts to drop. As the oil becomes thinner, it can no longer maintain the protective, lubricating film that separates moving metal components, allowing friction to increase throughout the engine. That's when a dangerous chain reaction begins. Higher temperatures thin the oil, thinner oil creates more friction, and more friction generates even more heat. This buildup is often referred to as heat soak, where the engine stores heat faster than it can get rid of it. Instead of stabilizing at a safe operating temperature, critical components continue getting hotter until they're well beyond what they were designed to handle. The symptoms can be surprisingly misleading. Many mowers run perfectly for the first 10 or 15 minutes before they gradually lose power, begin surging, struggle in thicker grass, or suddenly shut off altogether. You leave the mower alone for 20 minutes, come back, pull the starter rope, and it fires up as though nothing ever happened. The engine didn't magically repair itself. It simply cooled down enough to operate again. Unfortunately, every overheating cycle leaves its mark. Excessive heat accelerates wear on the piston rings, cylinder walls, valves, valve seats, and even the engine oil itself. Continue running the mower in that condition, and what started as a handful of trapped grass clippings can eventually shorten the lifespan of the entire engine. Thankfully, this is also one of the easiest maintenance jobs on the list. Once or twice, each mowing season, remove the plastic engine shroud according to your owner's manual and take a look underneath. You'll probably be surprised by what you find. Grass clippings, leaves, dust, spider webs, and sometimes even mouse nests can completely block the cooling fins without you ever noticing. A quick blast with compressed air, a leaf blower, or a soft brush is usually all it takes to restore proper airflow. The entire job takes less than 10 minutes, costs absolutely nothing, and can prevent one of the most common causes of premature engine wear. An air-cooled engine can only keep itself alive if air is actually reaching it. And while overheating can slowly cook an engine from the outside in, the final mistake on our list attacks it from the opposite direction by starving it of something just as important as cooling: clean air itself. The truth is, these little engines are incredibly forgiving. Most modern push mowers are built to last for years, sometimes even decades, because they're mechanically simple and designed to work in harsh conditions. But like any machine out there, they'll only take so much abuse before something gives way. So before your next mowing session, Spend 5 extra minutes giving your machine a quick inspection. Check the fuel, inspect the blade, make sure the cooling fins and air filter are clean, and confirm the mower is ready for another season. Your future self and your wallet will thank you. If you found this video helpful, make sure to subscribe, because we've got plenty more simple maintenance tips that can save you from expensive mistakes before they happen. The crankshaft also takes a tremendous amount of punishment. If you've ever clipped a hidden rock, tree root, or curb, the impact can bend the crankshaft by the smallest amount. It doesn't take much. Small engine technicians check this using a measurement called crankshaft runout, which tells them how much the shaft wobbles as it rotates. The acceptable tolerance is incredibly small, so even a slight bend can create enough vibration to shake the entire mower every time the blade spins. The damage doesn't necessarily stop there either. A hard impact can partially shear the flywheel key, which is one of the most misunderstood components on a lawnmower engine. Despite its name, the flywheel key isn't designed to hold the flywheel in place. Its actual job is to keep the flywheel perfectly aligned with the crankshaft, so the ignition system fires at precisely the right moment. If that tiny metal key becomes damaged after striking an obstacle, the ignition timing shifts,